Alright, here's problem 8. A farmer needs to construct 2 rectangular pens which will share a common fence on one side. The fence dividing the pens needs to be solid and will cost $10 per foot. That's not how you write $10, whatever. The other sides will cost $5 per foot. If each pen needs to be 300 square feet, find the dimensions that minimize the cost. Okay, so here's the picture I'm thinking of drawing. I suppose the pens don't have to be the same size, but I think that's kind of implied in the problem. Here are my 2 pens. I mean, they definitely have to have the same length here, so it'd be kind of weird if like this side was longer and that side wasn't. Like if this side here was way longer than this side here. So let's call this side X, and then of course this side and this side will also have to be X. And I think it's safe to say that we can call this side Y, this side Y, this side Y, and this side Y. It's perfectly fine to call each of these Y, or to call this whole length Y. Either way will be fine. Just remember that your equation is going to be different if you do that, right? Writing it this way, I can see that, let's see, so my cost equation, the thing I'm trying to minimize, is going to be, well, this one fence here costs $10 per foot. So it's going to be 10 times X, and then every other side is $5 per foot. So I'm going to have a 5X plus a 5X plus a 5Y, 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 5Y. So I'm going to have 5X, 5X, 5Y, 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 5Y. On the other hand, right, if you just called this side Y and this side Y, you would have a 5Y and a 5Y just twice. So just be aware that there is a difference. So my cost equation is going to be 20x plus 20y. And I'm trying to minimize that. Okay, I need a constraint. The constraint here is, right, the piece of information that needs to be true is that the area, which is x times 2y, has to be 300. Solving for either one of these, and either one should be fine. Let's solve for y. Y is going to equal 300 divided by 2x, which is 150 divided by x. So we're going to plug that in for y here. So I think I can erase this. Let's just go to the other side. So plugging in for y, right, I had cost equal to 20x plus 20y, and I had just found that y is 150 over x. So plugging that in there, I get cost equal to 20x plus 20 times 150 over x, which is going to give me cost equal to 20x. 20 times 150 is 3,000. Instead of 3,000 divided by x, let's write it as 3,000 times x to the negative first. So now we're going to find the critical values. Critical values are going to be, well, derivative is 20 minus 3,000 x to the negative second. Set that equal to 0. I'm going to rewrite this as 20 minus 3,000 over x squared equals 0. 20 equals 3,000 divided by x squared, multiplied by x squared. 20x squared equals 3,000. So x squared equals 3,000 divided by 20, which is 150. So x equals the square root of 150. Not plus or minus, right? We know it's not negative. It doesn't make sense for the side length to be negative. So x equals the square root of 150. And we need to show it's a maximum, right? Or sorry, minimum. We're trying to minimize cost. So look at our cost equation. Let's take the second derivative. I do think the second derivative test is usually the easiest way to show that a maximum, like an optimization problem, does give you what you want. Take the second derivative, it's going to be 20. Sorry, not 20. Taking the second derivative, not the first derivative. Derivative of 20 is 0, and minus 3,000 times minus 2 is positive 6,000 x to the negative third, or 6,000 over x cubed. So clearly, C double prime of any value that's positive is going to give you a positive number. Second derivative positive, concave up. So yes, we have a minimum at x equal to the square root of 150. Then we have to go back and find y. Well, here's our equation for y. So y is equal to, I don't want to erase anything, but I guess I will. I guess you can always go back and look at the video. I'll erase this right here. Y is equal to 150 divided by the square root of 150, which is, hey, guess what? It's the square root of 150. Let's make sure we've answered the question. Find dimensions that will minimize the cost. Yeah, I think it would be appropriate to say that each pen has dimensions square root of 150 by square root of 150. Yeah, so I do think setting it up this way is probably nicer. If you had instead set it up as this being y and this being y, if you found x, you'd say, okay, x is the square root of 150, and when you find y, you would end up getting y being 2 times the square root of 150, but then you would say that, well, each pen has half of that y, so it's still square root of 150 by square root of 150. All right, that's problem 8. Problem 8? Yeah, problem 8.